So, like I said, another way to integrate. So one way to do integration, one way to integrate is antiderivatives. We talked about that last week, right? The second way to integrate is something called estimating finite sums. It's easier, but you notice the first word says estimating. It gives you an estimate, an approximate. So it's not the best way to do it, but when we can only estimate, sometimes it's the best method, right? So it's probably the easiest method out of all the integration methods, but it's, like I said, it's just an approximation or an estimate, okay? Sometimes they're called Riemann sums. Riemann is the person who developed the method, okay? So Riemann is a name, okay? Sums, we're adding up, okay? So integration is a process. So what is integration? Like we said, derivatives are slopes of the tangent line, right? Rates of change. Integration is actually area. So anytime you have integration or integral or integrate, it's an area. Area of what? Area under a curve. Okay, so area under a graph. So you see the graph here, the blue, it's blue on mine, but I know it's not on yours. All the area underneath the curve back to the x-axis, that represents the integral. Okay, integration, that's what it is. In its core, bringing it down to its most basic form, integration is how we find area under the curve or area under the function. Okay, that's what it is. So when we say integral or integration, it's area. Okay, so when we find it's an area. Area, how much area is there? Well, today you could see it's not that hard to find area because they're kind of like boxes, boxy shapes, right? But it can get a little more difficult if it's something like that, right? Because those aren't boxy shapes, those are curves, right? So, so we will go into further detail later on, but one method is by using antiderivatives. So you guys already have a little bit. We didn't know what integration was, but you know how to find the integral by using antiderivatives. Today we're going to use another method. It's called rectangular, or sometimes we use trapezoid approximation method. Approximation means we come as close to the answer. It's an estimation, right? So this one's probably the easiest method, but it's an estimate, so it's not the best. Okay? So let's say that this guy, the blue guy, like I said, it's not blue on yours, I understand, but let's say this is the function. Now, if I was to find area under the curve, the easiest way for this guy is probably to make boxes, right? Probably to split this up into boxes, right? This is one right here. This is one here. That's one there, right? And then the area of the first one is a 1 by 1 square. So 1 times 1 is 1. The next box is a 1, or sorry, it's a 2 by 2. Yeah, it's a 2 by 2. Yeah, I read that wrong. So it'd be 4, right? The next one's a 2 by 3, so that's 6. The next one is a 2 by 1. And the last one's a 2 by 5. So we would add them all together, and we get 22. It's area, so we're going to say units squared. I don't know what the units are, but we'll just say units squared. In fact, I'll just write the word unit. Units squared. Okay? All right. That's when it's easier, right? And then this guy over here, it's similar, but just like smaller, right? Smaller slices. So we could break this up into blocks as well. Right? So the first one's a 1 by 5, so that's a 5. The next one's a 3 by 2. The next one's a 1 by 3. And the last one's a 3 by 4. So that's 12.
So 26 units squared?
So 26 units squared. So add them all up, you get 26 units squared. So when the function is something like that, relatively simple, right? But we're going to run into a lot of them that are more like this. That's how regular functions are, right? So the rectangular approximation method, or Riemann sum, says take this idea, right, boxes, and try to approximate using this guy, right? So one way to do it, again, if it's an approximation, there's a couple different ways to do it. One way to do it is by saying, okay, well, we can go up there, right? Because we're trying to get area under the curve. So I'm trying to get everything under the blue function, right? And then the next one could be maybe a little bit higher. And then over a little bit. And then over a little bit. Right? What I want to find is the area under the curve. So I want to find my goal is to find the area of the green. Right? The green is the area under the curve, under the blue, right? That's the green. That's what I want to do using rectangles. Right? And you can see it's an approximation because when I find area of these rectangles, I have my first rectangle is a 1 by 2. My second rectangle is a 1 by 3. Then my next one's a 2 by 3. My next one's a 1 by 3. My next one's a 1 by 1. And then my last two are 1 by 5s. All right? If I use this method, it's an approximation because this stuff in blue is going to get counted, right? The stuff in blue is going to be counted, and I don't want it to be counted. And then same thing here. This part won't be counted. This part won't be counted in my rectangles.
And the small particle too.
Yeah. And I want it to be counted, right? So all of that stuff, we just try to do the best we can. So when it's a curve like that, you just try to do the best you can. So if we use rectangles, we get, let's see, 5, 11, 15, 20. So is area under the curve 20 units squared? No. Is it approximately 20 units squared? Yeah, that's the best I could do, right? It's the best I could do. What's that? Did I add it up wrong? 11, 5, 11, 3, 14, 15, 25, yeah. Yep. Okay. Because it's an approximation, right? Okay, so now I want you to do the same thing. Use rectangles to find area under the curve for the second one.
Do we need to like do the approximate symbol in front, or do we?
No. Yeah. When you're doing approximations, you don't need the symbol, yeah. Okay, so do the same thing for the next one. See what you come up with. Again, it's an approximation. So is there an answer? Yes, but I don't expect you to get the answer. I expect you to get something close to it. So depending how you did this, I mean, that first one, you can make a rectangle like that. a 1 by 2, or you can go a little higher. This guy I probably would do like that. And again, the next one, there's no perfect answer to this. It's just as best you can, right? So the one I got a 1 by 5. I got a 3 by 2. I got a 1 by 4. And I got a 3 by 4. So my approximation is 11 plus 16, 27. Now, is that the only right answer? No. Some might have 26, some might have 25, some might have 28, 29, right? 30. It's an approximation, it's close, right? So that's essentially what Riemann sums is, right? Okay, so again, just explaining exactly what we just talked about on the backside. On the next page, on the back of this page, explaining what we just did. Rectangular approximation method, RAM, RAM. That's what RAM means, RAM. Rectangular approximation method, AKA Riemann sums. Okay? Explains exactly what we did. Now there's 3 types. The big part of this is there's 3 types of RAM. There's 3 types of rectangular approximation method. There's what we call LRAM. LRAM. The first example is an example of LRAM. And then there's RRAM. And then there's MRAM. So what is the letter? Left is LRAM. Right is RRAM. Midpoint is MRAM. Okay, so what do those mean? Well, this is an example of LRAM. Tell me why it's LRAM. Why is this LRAM and not M, middle RAM, midpoint RAM, or RRAM?
Because you're starting from the leftmost.
Yeah, look at the left top of the left. Each box, each rectangle, look at the top left. What do you notice about the top left point of each box? It touches, right? It touches. Every top left has to touch. That's LRAM. All right? So LRAM, every top left has to touch the function. Okay? Look at the one to the next. Is this an example of LRAM, RRAM, or MRAM? Because
It's in the middle.
the midpoint of each, the midpoint of each, right, touches. Right? Right there, right there, right there, and right there, right? The top left doesn't touch necessarily. The top right doesn't touch, it's in the middle. It's in the middle, okay? So that's why we call this one MRAM. We'll do LRAM in a second, okay? So it's the same function. Actually, it's the same function, but they're just 2 different versions of it. Okay, so if we were to find the area under the curve for this guy, what is that, a 2 by 2? So that's 4, right? And then a 2 by 4 is 8. So this is LRAM, and this is MRAM. The next one's a 2 by 2, which is 4, and then the last one's a 2 by 3, which is 6, right? So this one, we get 22 units squared. For MRAM, we get, it's the same function. Again, these are the same functions, f of x and f of x. Let's see what we get here. We get a 2 by 3.5. So that's 7-ish, right? We'll say 7. 2 by 3. Which is 6. 2 by 2-ish. 2.5 maybe. So we'll say 5-ish. And then the other one's a 2 by 4-ish. So we'll say 8. Those squiggly lines mean approximately. So close to 7, 6, close to 5, close to 8. So if we added all of those up, we'd get 13 plus 13, which is 26, right? Units squared. Mm-hmm.
Would MRAM be the most effective?
That's my next question. Which one do you guys think, just by looking at them, would be the most effective?
Why didn't we put the approximate value for the 26?
Oh, okay, yep. I probably should have. I just ran out of room, so I probably should have. A little squiggly line there. Also, that looks congruent, but you guys know what I mean. Which one do you think is the better approximation?
Probably the middle.
So how would we know which one's the better approximation? We don't know the answer, right? We don't know the true answer. I don't know what the area under the blue is exactly, but how would we visually, how would we determine which one does a better job?
Look at how much area is included and excluded.
There you go, right? How much area is included under the blue? And we want all the area under the blue to be covered, right? And we don't want area above the blue to be covered. So which one does a better job of that out of these two? I would say the middle, right? Middle does a little bit of a better job, right? LRAM doesn't necessarily do that great of a job. Actually, those might cancel each other out. You know, there's a lot more missing, right? I would say MRAM. I would say the true answer is probably somewhere closer to 26 than 22. Okay? Now, Ezekiel's asked, is MRAM always going to be the best? It depends on the function. It depends on the function. Sometimes LRAM is a better function, is a better way. Sometimes MRAM. Sometimes RRAM. So it just depends on which function you're looking at. For this function, I would say MRAM is the best. Okay? All right, so here's the process. Okay, so what we're going to do here is we'll do one together. So we didn't do an L, we saw an R, right? So we're going to build our own. We're going to build our own rectangles. Okay? So for these rectangles, we're going to use 5 rectangles. We're going to use 5 rectangles to cover all of the area under the curve as much as we can. The first one we're going to do is RRAM. This is going to be an RRAM. So RRAM means
It's on the right side.
top right of each rectangle. So how wide is each of my rectangles going to be?
2?
Here's the thing. Do all of your rectangles have to be the same width?
No.
For this problem, no. How do I know that? Because it just says use 5 rectangles. Sometimes it'll say 5 rectangles of equal width. Then they have to be the same equal width. This one doesn't say it. So can I have a rectangle that's 1? Yeah. Can you have one that's 2 width? Yeah. Can you have one that's 1.5? Sure. Right? As long as there's 5. Okay? As long as there's 5 rectangles and the top right corner of each of those rectangles touches the blue. Okay? So again, there's a couple different ways to do this if we're using only 5. Let's see. I'm going to use the dots since there's already dots there. See those blue dots there? Those black dots on yours? I'm going to use those as the top right-hand corner. So my first one's going to be, my first rectangle is going to look like that. I'm going to use the dots they've already created, just to make it easy. So my next rectangle is going to go up to 3 again. My next rectangle is only going to go up to 1 because that's where the dot is. My next rectangle is going to go up to 5. And my last rectangle is going to go up to 5 as well. So all the top right corners are touching the blue. Okay. So this is this is RRAM, right? Yeah, RRAM. Okay. So we find area under the curve. Let's see, the first one is a 2 by 3. The next one's a 2 by 3. The next one's a 1 by 1. The next one's a 1 by 5. And the last one's a 2 by 5. Okay. So that's 15 plus 13, 28. Okay. Now let's do LRAM. Now the top left corner is going to touch each dot. The top left corner. So we're going to use the same dots to build rectangles where the top left corner. So my first rectangle is going to go up to 2. That's the height. And it's going to go to the next dot. My next rectangle is going to go up to 3. Over to the next dot. My next rectangle is going to go over 1. My next rectangle is going to go over 1. And then my last rectangle is going to go here. Every rectangle is touching the blue on the left, top left. So we get a 2 by 2. We get a 2 by 3. We get a 1 by 3. We get a 1 by 1. And we get a 2 by 5. So 10 plus 10, 24. Plus 4. Okay. All right. So again, the math isn't that bad. We're just multiplying and adding. That's essentially what you're doing. Okay? All right, so let's go to the back. Let's do another problem. Let's do another practice problem here. Okay, so the difference between number 4 and the ones we've done before is now they've given you a function as well. They're telling you what function goes with the graph. It's going to go from x equals 1 to x equals 3. So from x equals 1 to x equals 3. That's the area we want area under the curve for. Nothing before, nothing after. Okay? So it says using 4 rectangles. So now we're going to use 4 rectangles to cover this area between 1 and 3. Okay? Between 1 and 3. So we're going to start with LRAM first. This is an LRAM. So LRAM means what? What does LRAM mean?
Start with the leftmost and then you drag it all over the dot.
Top left is going to touch, right? Top left is going to touch the function. So if the top left touches the function, and I need 4 rectangles, what would be a good idea for width of a rectangle?
1 by 1.
So 1 by 1. So if I do a rectangle 1, if my width is 1, how many rectangles am I going to have in there? Just 2, right? So do 2 more half, right? So we're going to do half. So the first rectangle is going to go from 1 to 1.5. And then the next one's going to go from 1.5 to 2. And then the next one's going to go to 2 to 2.5, and then 2.5 to 3. So what I'm going to do now is I'm going to go up and make dots where those happen. So the first dot is here. It's already made for you. At 1, I'm at 1. At 1.5, I'm kind of like right there. At 2, I'm right here. At 2.5, I'm right here. And then at 3, I'm up here. LRAM, I'm going to make start top left. So my first one is going to go up, hit the first dot, come straight over to the next dot. Okay. Next one is 1.5. Go up until you hit a dot, come straight over, come down. There's 2 rectangles. Next one, go up till I hit a dot, come over. And then the last one, go up until you hit a dot, come over, you're done. Those are the 4 rectangles. The hardest part about this, I think, is building the rectangles. Once you build the rectangles, then you're just multiplying and adding, right? So our next job is to figure out what the width of each of those is, right? We have 4 rectangles, right? So we're going to go in the LRAM box. The first rectangle, the very, very first rectangle. What are the dimensions of that rectangle? What by what?
1 by 0.5.
1 by 0.5, right? Or 0.5 times 1, right? That's the first rectangle. Good. What's the next rectangle?
Like 1.2.
Yeah, so the width is still 0.5, right? But the height, I'm not quite sure about, right? The height is it looks like 1.2, 1.25. I'm not quite sure what it is. This guy right here, I'm not quite sure what it is. How can I be more specific? It is an approximation, but we're already approximating. So we don't want to approximate an approximation. Then we get way off, right? So how can I
Counting the little boxes?
figure out what that
Use
is?
the little boxes.
That's one way, but again, you're approximating still. What's the way to get the actual height of this guy? What would be the best way to get the actual height of this guy? Use the equation. Because isn't this a dot on the graph? It's 1.5 comma something, right? Well, just use the equation. Just use the equation they've given you. They've given us the equation, right? So when x is 1.5, what is y? So let's plug that in. So the equation is 1.5 squared minus 2 times 1.5 plus 2. $1.5 squared is 2.25. 2.25. So it's 2.25 minus 2 times 1.5, which is 3, plus 2. So when we subtract, we get negative 1.75. No, negative 0.75 plus 2. 1.25? So the height of the second rectangle is 1.25. We only got to do that when we're not sure. Like the next rectangle, that's pretty obvious. How tall is it?
2.
2. So the next rectangle would be 0.5 times 2. Last rectangle. 0.5 times
3.25?
I think it's 3.25. How can I be sure though?
Plug it into the equation.
Plug it into the equation. Since we did it once, I won't make you do it again, but that's how you would do it. So it's it is 3.25. It is 3.25. Okay. 1, 2, 3, 4 rectangles. So the first rectangle, 1 times 0.5, you're going to get 0.5 plus. The next one is half. In other words, these are all just multiplying by half, right? So what is half of 1.25?
175.
Not points. Is it points? No, point zero something.
0.0.
The point 625. Yeah, 625. The next one is half of 2. And the last one is half of 3.25. I believe this is 1 point. Let's see, what is half of 2? Let's see. 1, 6, 2, 5. 1.625. Yeah. Add them all together. We get 1 point. Let me see. Let me see my notes. $3.65 sounds right. Trying to get to my notes to see what it actually is. There we go. 3.75. 3.75. Units squared. Okay. Okay. All right, next one. RAM. RAM. So let's go build it. So RAM. Again, make your dots. We need 4 rectangles. So the right top, top right, top right. So the first rectangle, second rectangle, third rectangle, last rectangle. Top right. So now I'm going to start, when I'm building the rectangle, I'm going to start from the right side of the rectangle. Up and over. Up and over. Up and over. And up and over. Now all the top right touches. Okay. All right, so let's go build it now. Or we built it, let's calculate it. So so all of the rectangles are 0.5, right? So the first one, first rectangle looks like it's up. How tall is it?
1.25.
1.25 again, yeah, 1.25 again. So 1.25. The next rectangle looks like it's up 2. The next rectangle looks like it's up 3.25. And then the last rectangle looks like it's up 5. That one goes all the way to the top. Okay. Well, some of these we've already done, like the first one, 0.5 times 1.25, and 0.5 times 2, and 0.5 times 3.25. The only one that we haven't done is the last one, and it's 0.5 times 5, which is just 2.5. So when you add those all up, you're going to get 5.75. 5.75 units squared. Even though it's the same function, you're seeing a difference, right? You're seeing a difference between them. One is 3.75, one is 5.75. Okay. All right, and then now MRAM. MRAM is the trickiest because it's not the top right, it's not the top left, it's the middle, top middle that needs to touch. Top middle that needs to touch. Okay, so again, we're still doing 1.5, 2.5, we still have 4, it's the middle. So the first rectangle is going to be 0.5 width. What's the midpoint of 1 to 1.5? What's the midpoint?
1.25?
1.25, right? That's where it's got to touch. That's where it's got to touch. So my first dot is going to be here. That means the first rectangle is going to go there. The next rectangle goes from 1.5 to 2. What's the midpoint of 1.5 to 2?
1.
What's the midpoint of 1.5 to 2?
1.75.
1.75. That's where your dot's going to be. That's where your dot's going to be. And that'll determine how tall your rectangle needs to be. The next midpoint is between 2 and 2.5. 2.25. Where is that at? That is right there. And then the last one between 2.5 and 3 is 2.75. That's right there. That'll determine the height of your last rectangle. Okay, so the midpoints, top middle, touch the blue. Okay. Last thing, find the area of each of those. This is where it gets a little tricky because some of them, like the first rectangle, it's 0.5, but how tall is it? A little over 1, right? It's a little over 1. How much over 1? I don't know. So how are we going to figure that out? By using what? The equation. What are we going to plug into the equation? 1.25. Good. 1.25. So it's 1.25 squared minus 2 times 1.25 plus 2. Okay. When you do that, it's 1.0625. 1.0625. 1.0625. Okay. Okay, so here we go. So select value, let's see. So we're doing midpoint, MRAM. That means area under a curve. Area under the curve from 0 to 8 using 4 subintervals. 4 subintervals. So here's the thing about these. Do I need to draw this graph? No. There's ways to do it, but sometimes it's hard to be visual using a table. So if you need to, draw the graph, right? I'm going to draw the graph on here, but I'll show you how to do it without the graph. Since this is our first one that we're kind of doing, I'll draw the graph. But do you need to draw the graph? No. Some people are like, do I have to draw the graph? No, you don't have to. All right, so 2, 4, 6, 8. And then looks like the y's go up to 21. So 5, 10, 15, 20, 25. So the first dot is 0, 21. The next dot is 120. 215. 314. 413. 512, 611, 75, 83. Right? So the function is like that. So we're not going to have time to finish this, but we'll do it tomorrow. So what we need to do now is create 4 rectangles to fill that using MRAM. 4 rectangles. So how wide would our rectangles be? 2. So we're going to widths of 2. Okay, widths of 2. So that's we'll pick up this one out. We'll pick up this one tomorrow. It won't take us that long to finish. So tomorrow I'm going to give you the rest of the time to do the assignment in class.